Hi, I'm Mike Skinner, Director of Engineering for the Colorado Asphalt Pavement Association. With me today is my partner, Tom Clayton, Director of Training and Membership. One of the things we'd like to talk about today is innovation in roadway materials and technologies. It sometimes can be very slow and difficult. Why is that? Because most agencies just don't like change. Change is a hard thing for all of us to do. And when we look at our local agency partners across the state and the challenges that they have, a lot of times they'll reflect on CDOT or defer back to CDOT and what CDOT is doing, how they do their processes. Tom, talk to me a little bit about the differences between local agency paving and CDOT paving and why one shouldn't rely on specifications, methodology, or procedures from the other. Why is that so important?
Well, Mike, let's talk a little bit. Let's go back a little bit before we get to that. Let's talk about the kind of the history of what's going on. That these local agencies obviously came around and started popping up after CDOT started building specs, and CDOT's got a full gambit of people that can put specifications together. And it's been easy for local agencies to just go, well, why do we need to reinvent the wheel? We have CDOT out there doing all of this research, and CDOT's got, labs and researchers, and they're gaining data from everywhere to put together specifications. So then the local agencies, the cities and the counties, the towns, have said, well, we'll just take CDOT spec and we'll apply them back to what we're doing. The problem with that is that it's fraught. What local agencies are doing is nothing like what CDOT is doing. The local agencies are out there building, low volume roads, and I'm talking about comparatively low volume roads. CDOT roads, even on their what CDOT considers a low volume road, would be maybe in a lot of cases an arterial or a collector in a local agency aspect. But CDOT has nothing that compares to what the low volume roads are for these agencies, the cities, the subdivisions, the cul-de-sacs, those kind of roads in and out of those subdivisions. So having the CDOT spec and building to the CDOT spec is truly overbuilding what you're trying to do. And that's why we've seen a lot of the problems that we're seeing at the local agency level with their roads being overbuilt.
The phone calls that we get at CAPA from our local agency friends across the state, I hear you ask them all the time. When you're on the phone with one of them, you'll ask them, how many highways does your local agency build, and how do you respond to that?
None.
Yeah, and then on the flip side, you ask the opposite question: how many local roads does CDOT build?
The same answer: none.
None. So that's a great way to look at it. Is then why are we trying to implement the same specification and methodology for while it's asphalt paving? They're two very different worlds.
Yeah, they're asphalt paving materials are asphalt paving materials. Are the local agencies, the cities, the counties, and the towns using the same materials that CDOT uses? Broad scope, yes, they are. They're using an S or an SX grading mix with sometimes similar binders. However, the gyration levels are where we really need to be thinking about. And once you start putting the mix design together at lower gyration levels, even though we're using the same rock, the same binder, basic things, but once you start putting those things together, we got a totally different ball game that we're going into. We're not playing in the major leagues here. We're down to the little league level.
Now, when we talk about quality, quality is at the top of everybody's radar. All of our local agencies, CDOT, the commercial market, et cetera. That's number one for what everybody we're doing. That's what we're paying for. That's what we're building, and that's our minimum level of expectation. In fact, we recognize that through our Best in Colorado Asphalt Pavement Awards, and the members that compete and in that program are very proud of the work that they do across the state. But high level, big picture, in the world of real estate, they'll always tell you, when you're shopping for a piece of location, a piece of real estate, it's location, location, location. And so we can apply that same thing to quality, big picture when we're talking about asphalt pavements. It's compaction, compaction, compaction. While there are a lot of technical things that we're involved with, the binders and the voids, etc. The big picture is compaction. And Tom, when you're out in the field on visiting projects, whether they be agency projects or commercial development, how important is that? Do you see that in the field, and how well does that resonate out on projects?
Well, there's a gentleman that passed away here just a couple of years ago. He's kind of was referred to as the godfather of compaction. His name was Chuck Deal. He worked for Bomag Americas. And I've got a quote in several of my presentations that I do, and it says that compaction is the most important factor that will ultimately affect the long-term life of an asphalt pavement, more than the binder, more than the gradation, more than the voids, more than anything. It's the compaction. So compaction is the number one thing that we got to look at when we're seeing these pavements go down. And the major producers in the state have, they went from, Mike and I, I've been around a long time in this industry for over 40 years in this industry. And I can remember that back with the producers, they didn't have quality control labs. They didn't have their own technicians, but every producer now has a quality control lab, and they have their own testers in place because they know the value of having that done, and they know what the value of making sure that the densities are there for the long-term life of the pavement. Mike, one of the things that you talk about all the time is the network. And maybe you could elaborate a little bit on the network, CDOT's network versus everybody else.
Well, when we look at CDOT is obviously the largest unique owner and entity, the largest network of paved lane miles in the state at about 24,000 centerline miles, but there are over 66,000 paved centerline miles across the state. So CDOT is only responsible for a small portion of them. The rest of that is on the backs of the cities and counties. It's about 72% of all the asphalt on the highway system. So that's a heavy lift. And so implementing best practices and moving forward for new construction and rehabilitation is key. Tom, you've got a video. Let's cue that up and watch that. And so just last year, the Federal Highway Administration, in concert with NCAT, put together a little 8-minute video about the importance of compaction and how the performance of our mixes in construction are heavily rely on compaction. It's a great takeaway. Let's take a look at that.
The backbone of America's economy is its vast roadway system. Our roads connect people and goods from one end of the country to the other, and asphalt is key to facilitating that connectivity. More than 18 billion tons of asphalt pavement are in place on American roads. Asphalt offers a high-performing, strong, smooth, durable roadway surface for the traveling public. Long-lasting, durable asphalt pavements are the result of collaborative partnerships between researchers, manufacturers, paving contractors, and agencies. These groups work together to engineer and develop optimal pavement and mix designs, materials, and equipment to improve asphalt durability and performance. In addition, they engage in research and collaboration about best construction practices and techniques to enhance asphalt's performance. When striving to make asphalt pavements more durable, research and lessons learned show density is an important factor.
Has a very direct relationship. The higher we go in density, the lower we go in permeability, which keeps water and air out of the pavement structure to prevent moisture damage from a stripping standpoint, to reduce oxidation of the binder that we've coated the aggregate with. From a stability standpoint, any mix is stronger to a point, the higher density we achieve in place.
The Federal Highway Administration directed an initiative to examine the impact of improved density on the durability of asphalt pavements. The study leveraged the collaboration between state DOTs, industry partners, and the National Center for Asphalt Technology at Auburn University.
we're actually working on that now, working on some projects around the country where we try to work with contractors to reach higher density levels, and so that we can follow those projects and see what the impact in performance is.
And we have found through studies that if we get about 1% more density, we can add 10% more longevity in the field. So we can add a lot of years just by getting proper density in the field.
Achieving proper density starts long before the paving equipment reaches the construction site.
So density is a construction issue, and it really starts at the plant. It starts with making the mix in the right way, with loading the trucks the right way, so that you don't have segregation. The big rocks and the little rocks are all mixed together real well, and when they get to the paver, they come out in a nice uniform way.
There's some things we can do in a lab to predict that. That'll tell us this mix either consolidates too quickly, it's going to take a little bit more effort and time to achieve adequate compaction in the field. So a lot of that again comes with really knowing your materials.
Once the asphalt reaches the paving site, it's important the contractor follow best construction practices. From properly applying a tack coat to correct asphalt placement to appropriate roller operation, each step works toward the goal of providing optimal pavement density.
And then it comes down to good paving practices and good compaction practices by the contractor to make sure that they are using a good rolling pattern, that they understand how many passes it takes with the rolling train that they have to reach the highest level of density they can.
There's a strong relationship between the cooling temperature of the mat and your ability to densify the mat. So there's a range of temperatures behind the paver where you can go in and aggressively do breakdown rolling and achieve a big bump in density behind the screed. And then as the mat cools, you'll come in potentially with some intermediate rollers like pneumatic rubber tire rollers and knead the mat as it cools, and then you come back with a finished roller and take the marks out of the pavement. And you get an increase in density with all three stages of compaction, but the biggest opportunity to increase density is with breakdown rolling right behind the paver.
Across the asphalt industry, new technologies help contractors deliver a high-performing product and ensure agencies make good use of taxpayer dollars. One tool to help monitor asphalt mat temperature is infrared scanning technology.
That really gives us an opportunity. We know temperature is that critical factor in getting density. So if we monitor the temperature at the back of the paver, we know what the product is that's hitting the road. We know how closely we need to keep those rollers, where they need to stay to ensure that we get a long life product.
There are also innovations that help improve roller operation and provide real-time data to the operator.
Intelligent compaction has been really a good add to our construction industry. We understand where we've traveled, where we've been, and where we need to go. So it is another important tool for our contractors to have in their arsenal to obviously achieve what we're all after.
A survey of asphalt mix producers found that more than 99% of the asphalt pavement material removed from roads and parking lots in 2017 was put back to productive use in new pavements. But how does the use of reclaimed and recycled materials affect the density of roadway pavements?
So the use of recycled materials really doesn't impact density. When we put recycled materials into an asphalt mixture, the mix can become a little bit stiffer, but there are technologies such as recycling agents and using softer binders allow contractors and agencies to still get great compaction on a mix with recycled materials, which will lead to better performance and better durability.
As the asphalt industry moves forward, partnership and clear communication among agencies across the country, as well as between those agencies and contractors, are imperative.
I think it's really important that DOTs specify their target. So exactly what they're looking for, whether that's a percentage of the maximum theoretical density that's achievable or a percentage density of what can be achieved based on the roller pattern that's established through the test section. You want to make sure there's no lack of clarity for your contractors as well as the inspectors that are out there on site. So that's one really important thing to write into and make clear in your specifications.
Increasing asphalt durability and longevity benefits everyone: contractors, agencies, and the driving public.
So agencies and contractors can work together to implement ways to increase density, which will increase our pavement performance and allow us to get more life out of the mix.
For more information about asphalt best practices and emerging technologies, visit the Federal Highway Administration's website.
It's interesting to think that compaction and the way we're going about compaction right now is innovative. It's been around a long time, but what's innovative about it is the objective study that's being done right now to show how that increase in compaction translates into extended surface life. But getting back to the concept of innovation and what is our industry doing to move forward, your slide hits the nail on the head here. If nothing changes, nothing changes. Let's talk a bit briefly about what's new, what's the new frontier on our industry and innovative as it relates to mixes.
Okay, well, let's talk about where we are. We can go back, 20, 25, 30 years, and we can talk about Marshall mix designs, which we have, for the most part, moved away from. We're still seeing some of that out there. We moved into super pave mix designs back in the mid 80s through the Sharps research. Well, when super pave started and super pave mix designs came into existence, it was never meant to be, well, we've got this new mix design and we're just going to live with it. It was meant to be updated and changed. There was supposed to be a Sharps 2 and a Sharps 3 and a Sharps 4. Well, we finally have come into Sharps research, the Strategic Highway Research Program, and we're now into what we would call Sharps 2, which is balanced mix design. So, why do we need to have a new mix design? Well, one of the things that happened from Marshall to Super Pave was there was a lot of rutting in the Marshall designs, and we came into Super Pave and said, okay, we got to solve this, but we can't ignore the cracking. And that's why we went to a design that would eliminate the rutting and try to eliminate the cracking, and that's through the PG binders. So we went to a new approach on the binders. It will resist high temperatures for rutting. It will work down in low temperatures to resist cracking. Well, the cracking that we see on a lot of these roads is not from low temperature cracking. A lot of the cracking is occurring because the mixes are so brittle. We've over compacted to take away the rutting, and we've made the mixes brittle. It's like peanut brittle. It looks great in a sheet pan, but if you hit it with a hammer, it breaks. Well, the same thing on a roadway. We put them down and they look great. Then we put traffic on and we start hitting them with that hammer and we start breaking them up. So we had to look at it, and the volumetrics, moving from the old methods to the volumetric methods, was a great step in the right direction. However, we are now have moved into that new direction where we need to be thinking about everything. So, like I said, the problems that we had, the rutting and the cracking. Well, now we're going to look at balanced mix design and move into the second phase of Super Pave, or a longer extension of what we've done with Super Pave. Now we're going to start addressing, okay, we know we've solved the rutting issues. We don't see rutting in roadways anymore. We might see ruts in a roadway that have come from a trench that has failed or something like that, but the asphalt itself rutting out, we don't see that anymore. But we do see cracking. We see early cracking. We see a lot of that early cracking. So now we have to look and say, okay, how do we adjust our mixes to eliminate that cracking, that early cracking, and the performance through that cracking? So, there's a lot of things that have gone out there, and there's been a lot of distresses that have been looked at. So, the question that we ask, and I have to give some credit here. You can see at the bottom of my slide here. This is Shane Buchanan. Shane works for the Old Castle Companies, which is now CRH. And they did a bunch of research, and they got a lot of information out there. And you can see that the cracking is from longitudinal cracking down to top-down cracking, and what percentage people think was their problems in their cracking. So those are the things that we have to be looking at, and we have to be aware of. Mike, I know that in your years as a pavement designer, those are things that you would look at in a pavement design. And how would you adjust as a pavement designer to eliminate some of this cracking? What would you do?
Well, the answer is simple. There is to increase durability and addressing premature cracking is to get more oil into the mix and maintain its flexibility.
And by putting more oil into the mix, we start pushing it back to that rutting side. So, we're damned if we do, damned if we don't, right? We hear agencies all the time talking about our mixes are so dry, they're so dry, they're so dry. They're dry because of what we did in the early parts of Super Pave to eliminate the rutting. And we've gotten mixes that are very durable. They don't rut, they just crack. So there was some research done in the last 5 years that was out there, and it talks about, what are the DOTs doing? What are the DOTs doing across the country? And they're to adjust their mixes so that we can start eliminating more of this cracking, but we still don't get into the problems with the rutting. So you can see what different agencies are doing. They've grade bumped, meaning it should be a 6422 binder, PG 64 minus 22, and they grade bump it to a PG minus 5828. A PG 58 minus 28. So they're grade bumping it to try and get a softer binder in there so that it won't crack. Some have lowered the design levels. They're no longer doing 125, they go to 100, or they go from 100 to 75. And we know of on the Ohio Turnpike, they are building at 65 gyrations on the Ohio Turnpike right now. They're using 65 gyration levels. There's a lot of other things that you can see in here of this chart. We've got 16 different items where people have adjusted their mixes. But you can see the last bullet point here is, talking about establishing a true point. Cause and effect is impossible if we have no idea what's being done. Well, we adjusted this and we adjusted that and we did this and we did that. Well, it doesn't look anything like what the original intent of Super Pave looked like. Now it's some version that we don't know of. And when we were putting this together, I commented to Mike, what I should really have put over here where this text is out here is I should have put a picture of couple of supermodels, a male supermodel and a female supermodel, and then over to the side put two zombies, because we started out and this is what we want everything to look like, these two models over here, but really what we've got is these two zombies because we don't know what they are.
Well, I think your takeaway here, Tom, is that the takeaway for me is when I see all of these DOTs across the country, including CDOT, this is their response to what they thought they needed to do to address premature cracking and also maintain rutting resistance. So you can see it's a very inconsistent message from DOTs. They all thought they were addressing it through different introductions of new specifications, and they become competing interests at the DOT level for material quality construction. So that's where I think as the industry has had to step back in, take 5 steps back and say, wait a minute, we need to design a new methodology for designing mixes that eliminates this inconsistency from DOT to DOT. That kind of was the basis in the beginning of a balanced mix design.
So we talked about testing. We've been doing Hamburg wheel test or rut testing for years to eliminate the cracking, and we've done that. We have eliminated the cracking. We don't see cracking anymore, so we don't have to worry about that. So here we have the balanced mix design is where we're going, and you can see on this chart we have 5 states that are fully implemented. We have 5 states that are actually working on balanced mix design, and then California has partially implemented, meaning they've taken some of it, they're still working on some of it. But the question is, where are we going? The path forward is balanced mix design. You can see from my slide here, this is the plan. We're over here and we want to get to the finish line. The reality is we're going to have all these bumps and dips and things that are in our way, and we found that out through our balanced mix design work group. Like I said, we have CDOT, we have lots of local agencies, but the big partner that we have in our balanced mix design work group is NCAT. We were able to secure NCAT to be part of what we're doing here in Colorado. So we're going to continue to keep moving forward, and we are going to move on to balanced mix design. And hopefully this year we'll have some things in place, and next year we'll be seeing projects out on the road, and maybe even later this year. So I want to thank everybody, first of all, for paying attention. Hopefully that there's been some good information. You can contact me through CAPA.
I think you wrapped it up well, Tom, is that stay tuned as CAPA continues as part of our mission of technology transfer, working with our balanced mix design work group at CDOT level, at the local agency level. And as soon as there's some progress that continues to be made through that framework, that information will be published and posted through the CAPA website. So thank you all for joining us today, and stay tuned.